Okay. Anyone who's online right now, please let me know. There's some delays that I wrote down with typing. So I need acknowledgement. It looks like Jake, you're online. Is there Jake in the room? So Jake, you're the only one online right now. If you can let me know if you can hear me. Okay. So to all of those waiting, it seemed like I couldn't log in because it was already logged in. So I apologize. The guy before didn't log out, which is really annoying. So yeah, we will get started now. So I'll just reinstate, there's a way for those who listen to this later. I don't know when it's going to get updated. For those online or who's going to listen to it later, the sheet that I'm showing on the screen right now, you can get through the ARC website. You go to, you can go to the main. Again, if you're online, let me know if you can hear me. Wonderful. Okay. So again, no. That mask. This just ended. That just ended. That was from 4 to 6. All right. Good night. Alright, so anyway, I won't repeat that then, but you can go to the ARC website or ask a fellow student, make friends, you can figure out where it is. It's under ARC, what was it? It was under the ARC website. Go to the main page, you go to ARC Scholar Resources, it's in the left, exam reviews, updated exam reviews, very top link, and then you go to MMAE Physics, and you find the most recent MS201 spreadsheet. Where it is. Why is it closing? So one of the first things that we probably should go over is your FCC and BCC. So welcome to MS201 review. We shall now get underway. If any of you do have complaints, I will put my name on the board. So you can do something. I do apologize for getting late, started late. I'm a grad student in the materials department. My background is in physics, so I'm learning physics and material. I know physics and I'm learning some more materials. So this is core to what I need to know. So I'm going to give you a background of what I know. I'm not a crossover from another department, I guess you could say. So you have your FCC and your BCC. What some of your homework problems were drawing crystal structures, right? I know some of you might have trouble drawing in 3D, so I'll just quickly draw what an FCC is. So FCC, remember, stands for face-centered. So if you have face-centered, you know you're going to have, and this is not the scale, right? Because you know that the atoms connect, they have closest radii, so I'm not drawing it correctly, but you know with face-centered that you're going to have the simple cubic structure, but then with face-centered, you're going to have one in the face of each of your, each side of your square. And then draw this a little bit better. I'm using dash marks for the ones behind. A little bit harder to see, so you have one back there, and then you have one here. So that's, remember, is what an FCC stand looks like. Not a big deal, but if you haven't seen it before, kind of hard. BCC, remember,
changes the structure, so it's still simple cubic, but then you have that atom inserted into the center of your cube. The things you should remember are, for FCC, you have the number of atoms are 4, because technically this is 1/8 of an atom at each corner, so 8 is 1, and then FCC, if you add up 1/2 6 times, you get 3 atoms. 1 plus 3 is your 4 atoms. Count a BCC and an FCC. BCC, you have a total of 2 because you have 1 whole atom in your repeating lattice structure. The other thing you probably should have done with your homeworks is to figure out or be told this relation. So 4R, the 4 radius, 4 times the radius of an atom is equal to square root 2, the lattice parameter. Remember the lattice parameter, because this is a simple cube, is the length of one side of your, one length of the side of your cube. The cube is 3 sides the same. You'll have to do this in some calculations. I remember, I didn't grade your quizzes, but I remember last year when I graded that one of your quizzes had you do something, if I remember correctly, you had to figure out the lattice parameter based upon this distance. I'm not really sure what happened because it was already open, and I didn't realize that, and I kept trying to log in, and it wouldn't let me log in. And then what happened is, I guess the previous student didn't actually end his session, so I ended his session and just started his session. So it seems to be important.
Okay, because I got a call at the monitor's desk like 5 minutes or so. Okay. Saying someone was still having issues with logging in, or couldn't see the other session.
Okay. Could you double check just to see? Like, if you were to close the UW Connect, you would have to still log on again, right?
Yeah.
Okay. So, I mean, I didn't realize that was it. So it's working now, but I guess someone might think this is labeled wrong or something. I don't know. Anyway, I was trying to log in. Do I have to use a different login browser to log in?
I think they should.
Okay. So I was trying to log in, and
What was the username?
Yeah, that's what I thought. I looked at an old email, and it was arc@iit.edu, and then I looked at the password, and I wrote that down, and it wasn't letting me log in. So I'm kind of just hoping that this session gets recorded, which it sounds like it is. Not really sure what the name of the session was.
Okay. Well, let me call Tyler then.
Okay.
And see, get credentials from him.
Okay.
See, I'll log in.
Does it keep doing that? Okay, so we're getting to this. So sorry, before I got interrupted. On your quiz, remember there was you had to figure out the distance, right, from a corner, and this is a cubic it was a diamond structure, and you had to figure out A based on this distance, the bond distance. One of the ways you could have figured that out, which is not too easy because this is diamond, is if this was BCC, you would know that this distance here had a relation with A, and you could then either memorize it or recalculate it, and you'd be set to answer the question. And especially on his tests and quizzes, you only get credit for very little time, so you have to be pretty prompt. The other thing you should remember is just discussion-wise that when you say AMU, that really means grams per mole. Just kind of remember your density. And also, not to get confused, but your density is, because it's a cubic structure, it's just going to be A cubed, as a reminder. Another thing that I wrote down, if you look at it later, is your mass is going to equal your number of atoms
times your molar mass, which is an AMU, and then divided by the constant to go from moles to atoms, or to go to cancel all your units. I think it's Avogadro's number. So any questions on this? Anything else? Yeah, so depending on your units. It's the easiest screw up on a tester quiz, right? You see the units, you get your brain going into robotic mode, and you just go and go and go, and then you get your results back, you get some really odd numbers, and it's probably because you're not working in the right units. So just double check that, and you'll save you time and stress. Any other questions on this? I'm going to go through all the concepts first, and then we'll go back through problems, because we started a little late. I won't end at 8 either, because we started at 8, so, unless you have to go check out. No? So Bragg diffraction. What?
Can you make it a little more clear?
Just like that, yeah. Okay, so with Bragg diffraction, you have to remember that you have infinite wavelengths that are reflecting off. And then he has on Blackboard the procedure he used to calculate, right? He went through the whole, did he go through the whole derivation
What is the
class?
username, Dan?
I'm getting mixed reviews now. Yes? Okay. Well, it's on Blackboard if you really want to see the mathematical concept of it again. And so what happened is, you probably have to learn about Miller indices first, because you can actually write down the Bragg equation in terms of your Miller indices. So what happens is when it gets back on, you have three main equations. One related to what's called the distance between planes, because we have because we're dealing with a cube, we have nice distinct planes. We have nice distinct relationships between atoms.
Yeah,
so
okay.
depending on the wavelength of the incoming the X-ray, it will diffract at certain distinct distances, which we call planes in orbital lattice, because you have a repeating lattice for the most part. So you're going to get one of those equations, which incorporates the angle of the incident wavelength that's hitting it, and you're going to get it's going to be in terms of your wavelength, which, remember, is probably going to be given to you in nanometers. So just make sure you're plugging it into the negative. You know, everyone knows micro, nano, milli, centa. Just make sure.
So now it should be working, right?
Yes.
Was this the page you were on?
Yeah.
Okay, so now he can continue.
Say, I'm sorry.
No worries.
Yes.
I don't know if anyone else is getting emails, but someone said that it's not screening on that.